Yeah, thanks everyone for coming today. I'm Chris Godwin, and we have a panel here to discuss I guess mostly the technical aspects of complex facilities and what's really required to get a system in and provide public safety coverage. So we'll just go around with a quick round of introductions, I guess. I'm Chris Godwin. I'm with RF Solutions. We're a systems integrator in New York metro area, and we specialize in public safety in building of, I guess, all sizes. So I've been involved in many complex facilities, both in New York City. Some of them would require 86 channels of public safety, as well as large-scale campus-type facilities. So we'll just go down the line here. Everyone can introduce themselves as well. Tom?
Sure. Thank you, Chris. Yeah, hi. My name is Tom Cooper. I'm with Avari Wireless, sales director. I've been in the public safety DAS space, I guess, about 30 years. Our company specializes in a particular niche within that, which is really including what we're talking about here, large facilities. We do digital fiber transport, and there's certain advances and advantages that lend itself for covering large complex deployments, multiple user groups. We'll talk about a lot of that type of stuff. So part of that, I have many other years in RF, so we really look forward to a lot of great questions from the audience.
Good afternoon. My name is Robin Mitchell. I'm the sales engineering manager for iBwave Solutions. I've been in the wireless industry for over 30 years now, starting out in system performance engineering, then in building and small cell design with Verizon Wireless, and I've been now with iBwave for the past 7 years. And iBwave is the industry standard for in-building wireless design. So that includes Wi-Fi, cellular, and public safety.
Hey everybody, Dan Leaf, co-founder and CEO of Gugli. Prior to that, spent 2 companies building and deploying as an integrator public safety systems. Along that road, that's where Gugli came up, and now we're trying to advance the monitoring and capabilities to look at these networks from afar, control them a little bit better, and kind of give insight to compliance. Talk more about it.
Good afternoon, everyone. My name is Giordano. I'm the Vice President of Engineering for RF Industries. We have 4 main business units that apply to public safety DAS installations, being Microlab, Schroff Tech, CNC, and CUI. So we do a lot with the passive infrastructure, thermal cooling, and passive cabling and fiber. And so I look forward to a nice comprehensive discussion with a great panel.
Great. Thanks, everyone. We'll go ahead and jump right in. Tom, why don't you get started? Give us some examples of complex facilities, maybe what makes a facility or a building complex.
Okay, thanks, Chris. So obviously you got some examples up on the screen. So complexity can come in different sizes and shapes. It can be one large multi-million square foot facility. It can be multi-building campuses. It can be educational, pharmaceutical, high-tech, biotech, etc. We're talking about complexity here in terms of system architectures, how you connect buildings together, typically using fiber, which is usually kind of the go-to type of thing in these large facilities. Some tunnel systems can be tens of miles long, dozens or hundreds of stations, etc. You need to communicate where the trains go between stations, etc. So obviously there's a lot of different types of facilities, traditional buildings, utilities, obviously nuclear power plants, hydroelectric dams. You can think of, sometimes people just think of that, it's just a block of concrete that's half a mile long, but guess what? It's really like an underground city. People need to go in there, they need to communicate, operate equipment, make sure everything's working properly. And obviously emerging applications as the world keeps changing. Everybody's into ordering things online, so every city needs warehouses nearby that need public safety coverage. Every time you open your phone or computer, you see AI all over it. So you need to have data centers nearby. So they're taking over the county landscape, taking up all the water and energy, and creating lots of jobs for people, et cetera, just sort of feeding the whole AI revolution. So these are kind of evolving as the world changes, new requirements for important coverage, et cetera. And these can be quite complex. A data center has a lot of servers going on. It's a very unfriendly RF environment. And you could also say that downtown anywhere is becoming complex because of you've got so many buildings and so many hundreds, and in some cases, thousands of BDAs installed over the years that you can almost stay warm on the rooftop just with all the RF going through the air. So complexity can be not only in the facility layout, connecting things over long distances, but also getting rid of all the noise and interference that you don't want. That can be more complex than just trying to get what you do want, et cetera. So lots of examples on the screen.
Yeah, thank you, Tom. And yeah, there's so many concerns in building a large extension to a public safety communications network. And you have signal delay issues, oscillation risks, PIM within each building or as they're connected and so forth. And we are, like you said, we are really looking at probably a fiber-based installation. But beyond that, you have to have a proper design and think of it really as a facilities-wide design. So, Robin, do you want to just give us an idea of what goes into a proper design for complex facility and how it differs from a simpler installation?
Sure. So usually with a simple design, a lot of times the consideration doesn't include the outer materials of the building, mainly interior materials of the building. And you're usually looking at one BDA. But the challenges with a more complex venue, as already been stated, fiber-fed DAS, you need to consider not only that building, but the surrounding buildings. So not just the interior design for the materials, but also the exterior. So having architectural drawings are really important. Those AutoCAD drawings will identify the different materials that have been laid out for the building. But the materials not only impact the signal inside the building, but how the signal leaks or signal leakage outside the building and how that signal can impact the neighboring buildings, especially in a complex campus design. I'll say that 3 times fast. A complex campus design, you can have interference between buildings and causing SINAR, not to mention if you have individual BDAs, you'll have a noise floor rise. So you want to keep that noise floor as low as possible. And the fiber-fed system does that. It assists you in managing not only the uplink challenges with that venue, but also you want to manage the delays, as already been mentioned. And you can do that with iBwave design by laying out the components, the cabling or the fiber-fed systems, as well as managing building material and the signal leakage outside the building, but also designing over the macro. Well, I'll say it like this. You'll be able to manage both the signal inside the building coming from the macro and outside leaking out. Traditionally, you've only been able to manage what's inside the building. You wouldn't necessarily be able to tell the challenges that the in-building system has on the macro design, how it impacts the uplink and also the handoff ingress and egress. But being able to do that makes it not only more efficient on the front end as much as you can address on the front end of the design. So when you do your site walks at the end, you won't be surprised by that signal leakage outside the building and how it affects the neighboring buildings. So that challenges, well, just to keep it in a nutshell, those are some of the challenges that you face versus a complex and a simple design for that complex venue.
Okay, great. Thank you. Yeah. Of course, all these systems have to comply with national and local codes and local amendments and ordinances, and you can have a lot of different agencies involved with them. And some you discover agencies as you go along, I guess. But Dan, do you just want to tell us how and when we can address these issues and what to think about going forward, especially in a multi-stage deployment or something that may have additional buildings being constructed over the period of several years?
Yeah, so we talk a lot about the design aspect, get it right. We talk a lot about the site walk to make sure the features and how you're going to design it, the approach is going to be correct. Then we look at the components you put in, making sure they're going to meet a lot of those requirements. What we don't talk a lot about, but it's happening more and more, and I think with the 27 code coming out, is monitoring them, being able to control not only the noise levels from the design output or when it was handed off, but then looking at the characteristics at the edge. So putting in a high rise, and the HVAC contractor goes up on the roof, bumps the donor antenna 20 degrees, there's no alarms that tell you that now the system's not functioning that it was designed for, and now you have degradation happening. So what we're pushing for, and I think on complex, is how do you monitor these things beyond the fire panel? How do you look at these systems to make sure as they're complex as they are, like we talked about more and more getting put in, how are they able to control that interference? How are they able to see what's happening at the input and the output of the uplink, downlink? And then being able to not only ensure these systems are working after they've been complied with at the code level, but annually are they inspected? That's usually when you find out something's missing or wrong, and the whole time nothing happens. So as we look at fire life safety, we think it's really important to look at these complex systems, whatever vertical you might be in, and how do you maintain that integrity of the system to make sure it's working when first responders come on. So as the code starts to evolve and as thought education happens, it's going to be really important to kind of push that as there's actually a savings and an ROI to monitor these things 24/7 versus annually. And so just, from our perspective, it's coming. It's not, some agencies are pushing for it now, but we see the evolution happening beyond just public safety systems, but cellular systems can be looked at as a public safety system. You go into a hospital, that ambulance has now a camera inside the back, talking to the doctor inside the hospital of what's coming so they can be more prepared for it. That's where this industry is going, is being quick reaction, quick data, and being able to act on it pretty quickly. So that's, from a code and as it evolves, that's where we see a lot of it going.
Well, yes, there's always a temptation to find the least expensive component. So especially in a competitive bid situation, Dino, why don't you just tell us a little bit about how do we choose the right parts and create awareness, and get the agency or whoever has a jurisdiction to accept that we may be putting in something more expensive than a competitor might be offering?
Well, I think the immediate answer is that we're dealing with complex systems. When you're dealing with complex systems, there's a lot, the active part, there's a lot of attention that's paid to it because it is complex. And passive infrastructure gets overlooked. It's like a commodity, so it's just, RF plumbing, fiber plumbing. It's just a transport. However, when we're dealing with like a FirstNet or LTE-based systems, that throughput is, it could be an issue. You need PIM-rated components. However, they're more expensive. And a lot of these complex public safety systems don't have the budget. So what's the first thing that's going to get cut? It's going to be your passive infrastructure, because a lot of attention's paid to the active. You need your signal. You need your good integrity. However, you need a transport throughout there. So your antennas, your coax, all your couplers and tappers and distribution is just important as the active. So the challenge is, with a tight budget like this, how do you, get the right components in there that, because generally PIM-rated components are more expensive. So it's very hard to sell that without going out there and having a failure. So unfortunately, bad brings in good. And I've seen that over the years where you get rip and replace for infrastructure because it doesn't work up to snuff. However, if you're going in and you're doing your iBwave design and you put those components in there and you can get them over your cost structure, it's just going to be an easier install for that moving forward.
So yeah, it's really a matter of working with the agencies and really not just telling the building owner that, hey, there's a cheaper way to go, but may or may not be acceptable, or trying to put something like that through, I think. And, oh, by the way, feel free to ask questions as we go about any of the aspects that we're talking about here. there's a lot more that still needs to be included in an upfront process to document everything properly for approvals and so forth. I don't know, does someone want to elaborate a little bit on that? Because it's going to be quite a package you put together to present and sell a system like this before it goes any further even.
I think one of you guys are probably better. We're the OEM, so you guys are more from the SI standpoint.
So one of the things that you definitely want to do early on is communicate with the AHJ, what the requirements are, whether it's the NFPA or FC, and what version that they're utilizing. Every jurisdiction doesn't use the same codes, which is surprising because you would think that it would be more common. But even FDNY, New York, they use their own protocols, their own guidelines. They call it the ARC system, so they don't necessarily follow the NFPA guidelines. And then some HJs actually use a more stricter guidelines than the NFPA. So knowing that up front is going to be critical. One of the things that we try to encourage HJs to do is to create a quick sheet of all the requirements, all the frequencies that are available, all the channels that are available in their area, including the maps that would identify all these towers that they manage in their jurisdiction. So you know when you're in an area that's near the border of a jurisdiction, your donor site that you're going to be utilizing is coming from the preferred donor and not necessarily the strongest donor, because the strongest donor could be coming from a different jurisdiction. And the only way you would know that is if you're in communication with AHJ early on in the process. So that's very important to have not only the channels, the frequencies, the technology utilized, whether it's UHF, VHF, 700, 800, if they're actively utilizing FirstNet or the Verizon government program. So you need to know that on the front end and have regularly scheduled meetings. Use that AHJ as a partner, not necessarily a validator at the end of the project. So by the time you get to the end, it's a formality to sign off because they've been kept in lockstep for the initial process. Once you get the floor plans. Once you get the floor plans for that venue, you're already communicating with the HJ about the needs for that facility from your initial site walk and grid test to the final site walk and grid test.
So the AHJ can require or have requirements that are more stringent than the codes under the national or state codes? Could they have requirements that are less stringent?
Well, those codes are the floor, right? That's the minimum recommendation. And for first responders, for fail-safes, you want the ceiling, you want the best, of course, based on what the budget will allow, right? You want to provide the best coverage for those first responders because we are dealing with lives. So we don't want to nickel and dime ourselves to death, but you also don't want to be so cheap that you put lives at stake.
All right, yeah, thank you. Well, Tom, why don't you tell us a little bit about why it's important to choose the right manufacturer for fiber DAS system? There are quite a few manufacturers out there. You have, several that seem to be similar to what you offer and so forth, and then some are quite a bit different. And how do you decide what is going to be acceptable, what's going to work properly, and what's not?
Okay, thanks, Chris. It's a lot of different questions to me. So, we offer a digital fiber DAS, which comes with a lot of inherent technical advantages in terms of performance, capabilities, etc. I think the real thing is if you just toggle through the slide here, Chris, what is it? I think it sort of comes in one at a time. There we go. So, what can digital fiber distribution buy you over, let's just say, compared to analog fiber DAS? So these are really some of the challenges that you can overcome in large complex deployments with digital fiber DAS. So the first is pretty obvious, just physical size. You can be looking at a single facility, one large building, maybe it's 5 million square feet, maybe it's an airport with 5 different terminals, you've got tunnel systems, etc. Subway systems can go tens of miles. We've actually sent RF signals over 20 miles. The second bullet really speaks to the fiber distribution, the available fiber plant. Typically in fiber DAS, you've got kind of a model which is like a spoke and a wheel. You've got the head end in the center of the wheel, then you go out by spokes to all the remote areas. That's very convenient if you have that, but you don't always have that. Sometimes to get to building number 7, you got to go over here, over there. You got to go through 2, 3, 5, etc. So you can do different types of routing. You're not basically limited by some of the fiber plant limitations that you have with analog fiber. We don't just go in stars. We can go in loops. We can go in rings, chains, etc. In other words, you can make the most efficient use out of existing limited fiber plant. And as far as the distance goes, we can go, again, tens of miles. So the technology is different. To Chris's question, we use SFP plugins. If you need to go further, you just put in a higher power SFP plugin. SFPs are a small form factor pluggable transceivers. It's about the size of a flash drive. So these are, tens of dollars. They're not thousands of dollars. They're not proprietary. These are off-the-shelf, low-cost components produced by the millions in the communications world. So the technology is different. The performance is different. The third bullet there, these are just some of the why digital fiber transport, multi-services. You can combine different bands together, different agencies, VHF, 450, 700, 800, etc. As Dino was mentioning earlier, you need good components to protect against intermod or PIM. When you're combining things digitally, it's just ones and zeros. So a 150 data packet and a 450 data packet, you don't worry about, things like intermods. So, the transport is different. The performance as far as fidelity, etc., is different. You maintain what Robin was talking about. You want to keep the noise down. You want to maintain your C2N, basically. You've got higher fidelity. It's digital. It's for the similar reason that radio systems have gone digital. It works as good as it works. It keeps going until it stops working. So if you need to go further, you get the same performance. You just put in a higher power plug-in. I think the last 2 bullets there are also very important. I'm trying to answer the question
No, that's good. No, thank you.
Without changing the subject.
No, I think that's very good. Yeah, I think so. You really are going to look for a manufacturer of a digital-based platform, and then whatever features or that you need. Of course, in a large-scale system, we need more than just the minimum, compliance-based survivability as well. Dino, do you just want to touch on the survivability side of things, and how can we make sure a system is going to be more redundant and have adequate survivability?
Yeah, having, again, I guess you just call it redundancy. Some of the systems you can have head ends and secondary head ends, so you have your master head ends, secondary head ends, and you run those in parallel. And you can actually even run your service side with interlacing antennas. So if you lose one of your head ends, that you can still get the coverage throughout that. Did a very large public safety install for VHF at the White House and all the Senate buildings, and that had a master and second head end fiber fed. This was analog fiber, again, pre-digital DAS, but that had interlacing redundancy with the antenna coverage along with 2 head ends. So it was a very large, it was 14 million square feet. So it was a lot of equipment. But again, we go back to the cost, factor in there. That had the budget, the Navy was running that, so it was that, put the best system in.
Yeah, well, what is it worth to you to have a system that's always going to be working, right?
For the U.S. Capitol Police, they wanted to have their, communications on spot. So most of the facilities don't have that luxury. So again, you run into that challenge where how can you make your best system and put as much redundancy and resilience into the system that the budget can handle.
Yeah. Very good, thanks. So let's presume we have a large-scale system. It's been tested and approved. Dan, what could commonly go wrong, and how do you ensure that a system always functions properly?
Yeah, we can look at it from, the maintenance side even. These systems are deployed. You look in this convention center, there's an antenna right there. How do we know if that antenna goes down until someone goes to key it up, right? So it could be either whether it's cellular, you can see it obviously on your phone, or public safety, it takes an emergency to come in and someone to try to key up and not get out. But also, as you look at these complex systems, whether it's millions of square feet or high rises or redundancy, it's more or less when it does go wrong, how fast. So I come from my prior years as an integrator. The hardest part is you have these systems put in, they get signed off, they're good to go. And then a couple months later, they're not functioning. You send a technician out there, troubleshooting starts there, and it goes until they can find it. When reality now, do these redundancy systems and the costs have to go into it? Or can we now put systems there that monitor at the edge that allow you, a technician, to walk to that one of 1,000 antennas to troubleshoot it, fix it, resolve, and move on? So I think there's some efficiencies that go with these as well. We've always focused on the front end of these systems through the acceptance side and then forgotten about. So that's where we're pushing our message is how these systems maintain visibility without human intervention, being able to watch these systems function as they should.
It sounds like that would be a great requirement for an agency or AHJ to impose then, especially on a large system.
Yeah, and we're seeing it.
So it's always being monitored.
Yep, and there's a lot of jurisdictions now that are starting to adopt it. Some of the bulletins that are going to be released here in the next few months will show 27 given that control. A good example is in San Francisco spent almost $2 million chasing noise out. That's it, So now can you control that noise level? Can you see that donor antenna from the knock and be able to shut it all off in a region and add one by one? And within hours now, you've identified the issue. So there's...
Yeah, otherwise it's going to come back as more systems get put in probably.
Exactly.
Right?
So there's a smarter way now that I think you can look at these systems to still control them, but offer that value to the tenant. And then back to everybody's point here, it's fire life safety. It could be property loss or it could be life safety, but either way, how do we address these issues faster and being able to give the comms through it? So.
That's great, thanks. Yeah, Dino, we were talking before this session about additional monitoring that can take place, much more advanced, and I was very surprised at how some of these systems and some of the facilities incorporate monitoring. Would you elaborate on that a little, please?
Well, a lot of these systems, you have your head-end DAS, and they're in equipment rooms that you have not just the DAS, you're gonna have your data equipment, everything, and these equipment rooms are temperature controlled, so they have many HVAC systems in there to keep that. So just by putting in an IoT device and monitoring, just the thermal aspect of it, how much are these HVACs working, all year long? A big problem when you're setting these HVACs up and everything for a room that's temperature controlled is we're humans, and we set them up for, your human being comfortable. However, your equipment, that's the ones you're trying to, save. And they're not human. So again, you have a different temperature scale. So sometimes you're running these rooms and they're way overkill for what you want to keep your equipment. So just having that monitor aspect to look at, hey, the current draw of why, and seeing how the systems are constantly running, and say they don't have to be that way. We're seeing our temperature, and our temperature is way below the normal threshold. We can run them less, and that's just by putting that monitor aspect. Additionally, for our cost factor is that in some states and jurisdictions, they have energy rebates. So if you have that data and you can show that, hey, first of all, I saved this year by running my HVAC, so you're getting that capital cost right up front. However, you show that data to utility companies and they're running a green initiative, you're going to get a rebate for saving that energy throughout the year annually. So just by having that monitor aspects in those IoT devices out there, you can run these systems a lot more efficient. And they tag along with something that Dan's offering, so he's monitoring the health of the system. It's just SNMP traps at that point. It's like your digital fire panel. We're just collecting all that data. And rather be a third-party NOC or cloud system that's based there, you can bring all that data together in a collection. So basically your cost is all up front and it's all rolled in together. So.
That's great, thanks. Does anyone have any questions? Okay, well, let's, yeah.
guarantee, like the Senate, the temperature.
Yep.
Isn't this one, in case of emergency, let's say fire?
Yeah.
So is this one protected like the DAS system?
It would be rolled into that, you know, and it could have that, you know, like again, these can be in fire rated boxes that have that control because that's your intelligence. So especially if it's a head end system, it could be a rack mount system where everything is incorporated within that. And you can incorporate temperature. Now you could put temperature sensors throughout that room, that building. It's all collecting data. So it can show you, you know, if you're getting escalation, you know, within there, if there is an incident in the building, they can run those things. I think, Dan, your systems does the same thing, has the, you know, the temperature hooks and everything to show that.
Yeah, it's just, you know, these systems are required to be put in. Let's put some value to the building at not another cost, right? We see that a smoke detector takes, and don't quote me on this, about 7 minutes to detect that change in the environment versus temperature, it could be within seconds. So now, is there a value to the property on top of the comms by have that temperature to be able to see, one, is the HVAC broken? Two, now is there something happening from a loss to the building and property loss? So yeah, IoT is going to become part of this. Is it writing the fire code across and then being able to add these bells and whistles to it? I think so. That's when the property is going to get more involved of why are we putting these systems in? You don't need these multiple layers. You can bunch them up all together now. Data centers, humidity, all while protecting the comm side. So I think it's an innovation that's happening, and I think over the next couple of years, we're going to see that start to take shape in how we look at these systems and monitor them. Then, well, what value are we giving to the property based off of the requirement that the fire code's asking for?
Yeah, I think with continuous monitoring, then we're being more proactive instead of just reactive, you know, with the 7 alarms or whatever's required, you know, supervisory alarms in a system. And then, you know, eventually somebody shows up, but there's no sense of urgency or anything in a lot of these systems. So somebody really has to be responsible for doing something with the information gained from the monitoring as well. And I think, you know, the equipment is capable of sending out a lot more information than just the basic alarms as well, as far as the health of the system, whether it's fiber remotes and, you know, changes in fiber loss out to each remote or anything like that. There are just so many parameters you can monitor, and probably if you can incorporate it all and then, well, I hate to say using AI, but something to, you know, to really analyze it, see what the baseline should be, and look for small changes. And I guess not just, you know, not just the larger changes. Yes, yeah.
So just to kind of give an example to support that, BYU, one of our initiatives recently is taking our solid system and is integrating it into our monitoring software at our IT building, and we use Dynatrace to do that. And my current project is going through, it's called an MID, not like a movie, unfortunately, but the MID file, which has a list of probably about 100 different alarms for the health alarms in the system. And I'm supposed to go through each of those and label if they apply to any of the fire code required alarms or not, and then assign an incident level to it. P4, which is the lowest, we can solve in 4 days, up to a P1, which we got to get done in 24 hours. And so yeah, we have the alarms coming in, but right now we're actually trying to figure out how do we get this all done so that our 24/7 monitoring team of students can actually then call our fire marshal as needed to let them know when there's a problem with the system. And tell you what, it's a challenge, but it's quite fun.
Can I answer that a little bit?
Yeah, oh,
So
sure.
we just put this together for the FDNY, and they wanted the same thing as these different type of troubles or alarms, supervisory, how they're routed, and then how they're going to go to what the knock goes, or maybe just the technician piece of it. So there's software out there that will start to create, taking those alarms, interpreting them, and then escalating how you want them as a university or a campus based off of that. So there's some good innovation happening in that part of the world of not being able to decipher it, but letting software do it for you and routing it as necessary.
That's good to know. Thank you.
Yeah, I think just, you know, depending on an alarm monitoring company, when they see a supervisory alarm, to, you know, realize that, hey, this is a critical infrastructure really, and something needs to be done. I think we need to go far beyond that, certainly. So yeah, thank you for sharing that. Do you want to just start here with Tom, and if anybody wants to describe some of the biggest mistakes they've seen regarding scaling of a complex facility or installation, because a lot of things can go wrong. You try and, cover things, but sometimes, when you least expect it, you stumble over something. And anything come to mind, Tom?
I guess I go back to the toolbox analogy, starting with the wrong technology and trying to stretch something into something it wasn't necessarily designed for. As an OEM, we're not involved in construction or design typically, so those types of questions would probably best be answered by those folks.
Sure.
But there's always things you can get wrong as far as the it's not all about selecting the right materials. It's about having the right knowledge, understanding, design. These
Well, we can
systems,
just call the manufacturer then to come fix it, right?
or blame the manufacturer because
yeah.
the installer didn't know how to terminate a connector or something like
Yeah.
that. So it's a system. Nothing works better than the weakest
Yeah.
link allows it to. You can kink a cable and wonder why.
Oh, we just straighten it back out above the ceiling, and
No one will see it.
no one will know until
Exactly.
until they know.
Yeah, so it's in all fairness, Chris, it's really not the part of the industry as far as practices and stuff, other than the equipment. I guess understanding the requirements is the main thing. These gentlemen mentioned you got to have the frequencies correct
Yeah.
to start with. You have to have experienced people that handle everything from design to installation, to commissioning, to optimization, to monitoring.
It all has to work together, really.
It all has to work together. As Dino mentioned earlier, and people sometimes underestimate the importance of small passive components. It's great to have a directional coupler. It's not so great to put it in backwards. So, you see things like that. So,
And you can have hundreds of couplers in a large system. So
I'd rather these fellows.
that's fine.
from the,
And
field
actually,
and construction
we
standpoint.
had a system we installed, but it was for a new county courthouse. And the county has certain requirements. They have UHF trunking system and a couple fire channels, and that's all they require. So we did the design, everything's good. We go on a site walk, the building's partially completed, and it's like, what are all these jail cells down in the cellar? Oh, well, that's where the sheriff's department is going to house the prisoners until they bring them up. They have a separate elevator to bring them up to a courtroom. Well, of course, the sheriff's department's on an 800 megahertz trunking system that was never thought about or even required by the AHJ. And of course, then, how do the prisoners get there? Well, the state police are going to bring them for the most part. And it just, if you aren't given the information, it's like, how are you going to know until, so it's really a matter of, you have to, keep drilling down, even if it seems like stupid questions or whatever, but it's, you want to put in the right system in these cases.
Chris, you reminded me of something. I could have said it earlier, and that is more to Robin's side, is you got to have the right floor plans and you got to know the right building materials. And, we, as a manufacturer, sometimes we assist the designers and we can review iBwave designs and this and that. But, you have to have the right information to start with. And if there's walls where nobody said there's really walls, or, other common sense things, hey, it's a warehouse, there's nothing in it. Well, whoops, what happens when it's full? So, just making sure that what you understand you're starting with from the real world perspective, whether it's designs, architectural plans, the building itself, everything has to be correct in order for the system to work. Anything can be wrong for anything to go wrong. So that's more on the design.
Yeah, Robert, I bet you get some strange questions sometimes too from designers or people who think they're designers trying to put together a system.
Some of the things that you see quite often is being able to bring in survey data and incorporate it with the design. Sometimes you don't have all the building materials, like if you don't get the AutoCAD drawing, How do you manage that design without the AutoCAD drawing? So you do have to create what has been deemed as a digital twin to accurately design the most accurate design for that facility is knowing the material walls. But if you don't know that there's rebar behind this wall, or this is a firewall, or there's 6-inch concrete on the other side of that wall, you won't know that until you do a site survey. Or even, you may not know it even after doing the site survey, but doing a data collection of that area, you can incorporate that in the design and calibrate the design based on that site survey data. So that's one of the things that a lot of system integrators may miss that particular step and realize they may have over-designed or under-designed because they didn't account for the proper building material that's in that venue. So a lot of HJs don't realize they need to verify the material in the design. So even
They
though
just have simple PDF drawings
Yeah.
sometimes of the building, and it's a lot more work to take AutoCAD, floor by floor and import all the different wall materials and everything. But it sounds like, it's pretty much a requirement to get a proper system out of the design.
absolutely, because you can under-design or over-design if you don't properly model that building.
And and putting in too few antennas, whatever, certainly having to go back is not the way we want to do things, right?
Exactly.
Yeah.
Well, I've been guilty of that, where I never really got AutoCAD drawings to do the design, so I can remember one where, just did the design, drill walls, basically, whatever, double sheetrock and all that, put in there. When they went to install, because I always work for small companies, so we never had the time, and this goes with planning. The install went over and they found out they were all keyed doors. They were metal doors too. So I didn't put metal doors in there. I put regular wood doors and everything. And they're keyed, so they're shut all the time. And then there was no indication where firewalls were too. So there's a few rooms that were very lacking power signal because, you had to go through this firewall. So I just emphasize with planning, as much planning you can do up front with the design, with the installation, because these guys, they get out site, they want to install, and they'll do whatever. They'll run to Home Depot and make things work. So if you don't have a good plan up front, more things are going to go wrong, and they're, human nature. You're just going to go out there. You're going to do what you got to do to get it done. It might not be proper, but that's all the, all the tools that they have that's given to them. So really, the upfront planning for both the design and installation just will help out, the whole, process.
So, it's really complex right from the beginning, then you're saying, right?
Yeah.
Yes.
That's a question. So does the coverage moderate based on statistical, calculation or electromagnetic simulation? And how you balance between hearing with the dead zones like the elevators or stairs or stairwells or the blind spots and the oscillation when your donor, antenna, and glass are on line side?
That's a big issue, certainly. And again, it goes back to the design and, having it right and using the right software really to model the situation. Robin, you want to talk a little more about that?
Yeah, so the propagation model is a fast ray tracing model, which does use the EMF propagation indices of that venue, as well as the technology, the frequency, the antennas and the pattern associated with the antennas. So you can manage that design, optimize that design based on the materials, because you have materials at 700 megahertz will impact the materials differently at 1900 megahertz or 2100 megahertz. So all of that is incorporated in that propagation model, that fast rate propagation model. So knowing that up front and being able to include that in your design is going to be critical. You had about two other points that I wanted to make sure I captured all of your questions.
What is basically electromagnetic simulation or statistical, like recordation, like probability?
It is electromagnetic propagation model.
But
So
it's a
from
prediction
statistics-
based on that.
Yeah, but we actually have a statistical model where we use Monte Carlo analysis now, where we can put in a randomized user base, and you can set the number of users at any level and do up to 999 iterations of that. So you can get a statistical model of that as well and manage that from an uplink perspective.
Well,
Dead zones and blind spots.
Sure. So in dead zones, by using that propagation model and appropriate wall materials, you can identify dead zones very quickly based on that wall material, whether it's a stairwell with reinforced concrete or elevators that are metal, right? And that bank of elevators in that area that shield signal from all around the rest of the facility. So you can manage that up front and know whether or not you need to rearrange antennas, use different panel antennas as opposed to an omni antenna to address those type of scenarios.
I think, yes, stairwells are always considered a critical area.
Absolutely.
So they have to have 100% or 99% coverage, but oftentimes you have to put antennas in the stairwells, and you can, direct just maybe a small amount of power through the right, tappers or splitters and directional couplers so that you balance the system in the software, but also make sure there are no dead spots. But as we mentioned also, you don't want to be necessarily leaking a lot of signal outside the building through the windows, or, if they have overhead garage doors in a warehouse or something, when the doors are up versus when they're down, you don't want to be interfering with the outside, the macro network, on any of the systems that are part of your system. So there's really a lot involved up front in, designing and getting the right, the right mix of antennas and power and fiber remotes and so forth, without going into overkill either, but to come up with the optimum, I guess. So, and there's not always just one optimum solution, but there's, usually some are better than others. So it's a matter of, having the right design, and then being able to describe why you have to go this route as well, I guess, and validate, the choices you made and so forth. Right.
Absolutely.
Also over design. Some people or some integrators decide just to blanket it with power and antennas, and that has a reverse effect. So you turn it on inside your building, it looks good. Now the macro network and the engineers and the licensees are now. So when it comes to like public safety, it's important to not over design as well. It's easy to do to be safe, but that also has a reverse effect. So as you turn that thing on, now it's a bigger issue to the macro. So kind of a fine line between just doing it right, from the get-go.
Yeah, and I know you mentioned, I guess, basically oscillation, where the inside antennas have a signal path to the outside antennas, and that's really one reason why a lot of BDAs in separate buildings is not a good idea, because the buildings can interfere with each other as well. Just having antennas shooting over top of other buildings and so forth, so you really want to watch that. And again, it all comes down to design, and I guess understanding kind of the big picture and how, complex facility fits into, again, the macro network and other facilities and other buildings, and, what's being planned, what's going to be constructed over the next couple of years, and really, selling it that way, even though you have a building owner who, wants the least expensive installation probably.
You mentioned the isolation challenge. One of the reports we give you in iBwave is an isolation report. So you can see which donor or which coverage antennas may be causing or higher than that 20 dB difference that you need between that donor and the coverage of that Yagi antenna that's pulling the signal in from the donor
So
side.
you may need to relocate the donor antenna as well if there's, if there are choices. But if you need coverage on the floor directly underneath it, then it's quite a balance to get that and have, required to have at least 20 dB isolation beyond the gain setting of your PDA or your system. So you have to, if you can get 100 dB of isolation. But you also have to test, the different fiber remotes. It might not be, it's not necessarily the closest antenna either. That's could be the isolation issue. So you have to, test them all, and there's a lot just to commissioning a system too. So, I don't know, does anyone have any additional questions? Is anyone in the middle of implementing or designing a system like this? Yes. You want to tell us what what your experience has been so far.
Talk about a complex system. I'm not a radio guy. I'm more of I served in the Utah National Guard, so I am more of an operations center manager, right? But I know how important radios are. It's my most important form of communication. So they gave me radios, and I came into this, found out a little bit about DAS, and there was hardly any documentation on it. So for the past 2 years, I have been going from building to building, scanning each building, and then also tracing coaxial cable and all that stuff. Like, it's been tricky because one of our buildings has high frequency. One of our science buildings, they do a lot of not exactly sure. All I know is that there is a lot of RF going on, and it's 3 floors below the ground to try to isolate that area. I'm supposed to put gas in there.
You have a lot of noise of some sort.
And then we have our missionary training center, which has trouble because it has a whole wall of bulletproof glass. That's one of my issues right now. Long story short, and also we had like 8 to 10 DEAs on campus. Then I have a bunch of other custom stuff I keep finding as I go through it. So it's a very complex environment. Long story short, though, how we've solved it is we've taken a data-centered approach where we make sure, the nice thing is we have students as our cheap labor, you know? We pay them good, but not as much as a radio engineer. And we have them walk the buildings and get a detailed scan. We don't do the 80 by 80 foot, maximum scan.
The grids, or yeah.
We made it so that the requirement is they are going by 40 foot by 40 foot squares. And as we've done that, we have been able to identify the trouble spots and actually been able to find the old equipment and identify where we need new equipment. And we're also starting to go into the iBwave area now to try to help us in figuring out that analysis too. So
Are you thinking it's gonna be a rip and replace of everything, or just some buildings, or?
it's going to be both.
Okay, yeah.
Yeah, it's going to be ripped and replaced in some buildings, and some buildings I found out to save costs, some of the equipment is still okay. It's good enough, and we've assessed that the risk of the life cycle of that equipment is within what we're willing to accept. And because we're going to be scanning that building every year, we're like, we'll know when we need to replace it or put it onto our roadmap.
So yeah, somehow these things were just built one after another, and nobody saw the big picture, it sounds like.
Yes,
Until you inherited it.
yeah. The thing that got us was there was no documentation, there was no planning, and there was no data to back up what was installed in the past. So now we're having to do all of that in addition to, while trying to keep it going while improving it along the way.
And I think that's happened in a lot of cases as well, where it starts off small, or you have different people just putting in whatever is required, or maybe it's not even required. They just, think it's a good idea or something, and then all of a sudden, you have a big mess or a lot of uplink noise, or whatever. You just can't. There's no way to get the performance out of that. So you really do need to take a holistic approach or something, but to the overall campus environment.
Yes, that's the other point. Thank you for pointing out holistic approach. That's my last thing is I noticed that people hyper-focus sometimes, individuals hyper-focus on an individual building without considering the bigger landscape and who the neighbors are.
Yeah, and you're right, and the macro networks as well that you're trying to bring in. So, yeah. Anyway, thank you. It's, that's what we do for a living, is solve problems like that. So
We feel its pain.
yeah, we feel your pain. That's right. Exactly. Yeah, we've been there and experienced it. Right. Absolutely. Does anybody have anything else they want to add here?
I'll just, I think what you described is very relevant to what you see on the screen there. So that's a campus type deployment.
Yeah, that has two head ends and
Yeah, so this has got different layers to it. This also talks about fault tolerant is another term for redundancy. So, this is a scenario where you've got two primary off-air pickup locations. You can see each of the secondary head-end sites is connected back to each of the two head-end sites. You see a purple and a yellow fiber, and then you see from there at the bottom, you go out and you fill the adjoining buildings. So forgetting the redundancy aspect for now, but just looking at the fact that you have one overall controllable network instead of 5 or 7 or 8 competing networks, et cetera. So this speaks to, a term you hear a lot of in this industry, which is too many BDAs. So if each of those buildings, each of your buildings has a pickup antenna on the roof, all pointing towards, forget the second one, say it's maybe just the two towers at the top. They're crisscrossing each other. One's hitting the side of this, the back of that, etc. They're all spraying the donor site with noise. It also segues into something we're talking about in an earlier session, which are rule changes and technology changes. So, going to the cellular example, they don't do it like this anymore. They don't want people to put BDAs in every building. It's called bring your own source, and public safety is learning from that. And so some jurisdictions are basically saying, you can't do this anymore. You can't we already got 1,000 or 3,000 BDAs downtown. We don't want any more. We don't want another 10, 20. You can't keep making the problem worse. So it's migrating to who's going to bring the source. So it's, it's an economic thing. As a responder agency, are they going to bring a site onto your campus at their expense? Well, maybe not. I don't know how many buildings you have or how many students, et cetera, but that's something that's happening in the industry. So when you kind of eliminate the problem of the off-air interface, you eliminate a lot of the problems. And so also when it gets into things like managing overlap and TDI and interference and capture, stuff like that, there's things you can do. So instead of just having a high power transmitter site on your campus, you can actually have outdoor coverage through other remote units, and then you can control the delay to each remote unit. So it's sort of thinking outside the box. So as new technologies come along, you can do things completely differently. So that eliminates, the problem with the overlap, the indoor or the outdoor. You can kind of make it, you can make it one and the same. You can add delay where you need to add delay, things like that. So
yeah, and then as we mentioned, centralized monitoring of everything as well. So it's the same building after building. It's uniform, and you get alarms and notifications that are useful to you. Because sometimes we just get a notification, something failed in a fiber-based system, and it doesn't tell you what it is, and it can take a lot of time if you have to get into different buildings and so forth, just to to troubleshoot and find out where the problem is, much less what the problem is. So, all right. Well, does anyone else have any questions? Okay. Well, thank you very much for attending here.
thanks, everybody.
Thank you.